All right, welcome back to Computer Science Principles. This is Unit 1, Digital Information. We are on Week 2, Lesson 8, Color Images. So, as a warm-up, I want you to think about how many different shades of the color blue can you name? How many do you think there are in total? All right, so put that in your journal entry. How many do you think how many different shades there are? And then how many can you actually name? All right, so pause. We're going to move on. All right, our activity. First thing we need to go over is how do you create colors as far as the computer is concerned. So maybe you've taken this in art class or digital, some kind of digital art class. But the bottom line is it's RGB, red, green, blue. How red is it? How green is it? How blue is it? So red would be 255, 0, 0, because it's all red and none of the other colors. Now this is called the RGB. So when you see it in this format, this is normally called the RGB format, although these are decimal numbers as opposed to hexadecimal. But it's all the same format, RGB, red, green, blue. 0 red, all green, 0 blue. Now also notice, I said all, there's 255, right? Shades that the RGB system, i.e. the decimal, which is because of binary, right? If we do this with binary, that is 255, so that's how many bits is that? How many bits is 255? Right? Hopefully you said it's 1 byte, which is 8 bits. So 8 bits, 8 bits, 8 bits. So 3 bytes can give you RGB using this system right here. And then you can see blue, 0 red, 0 green, all blue. Now, if you go down here, you can see like there's these color pickers. So you can go to HTML color picker and get these numbers. You don't have to have all of them memorized. You just need to know the order of them. And then the more there is, the darker it is. So in this case, this one has them down here, 39 red, 129 green, 96 blue. So again, mostly green. And that's what this shade is right here. Can't really see it very well over there, but that's what it is right here. Also, there's a hexadecimal. So let's go over that real quick. One of the biggest things you need to know, we're going to go over how hexadecimal works, but FF is the top. That is 256. So actually there's one more shade in hexadecimal. So I mean, in theory, you could say there's infinite shades because you can infinitely half something. But as far as the internet's concerned, depending on which one you use, 255 or 256. So just know FF is 256. So full red, 0, 0 is all red. Also note that you can do F00, and then that is actually 16 red, 0, 0. So also there's a lot less shades if you do it this way, but it's, it can work, right? And then there's green. Remember, it's RGB, so all green is green. Same concept over here. No red and no green. All blue gives you blue. So if you can kind of understand these concepts, again, we'll go over how hexadecimal works, but 27 is, well, it's 39, right? So it's 16 times 2, which is 32, plus 7 is 39. That's how hexadecimal works. Now, again, you can do the math, but 18 times 6, B is like 11, so you add those together and that's 139. So basically, if you see a higher number or a letter on the left-hand side of it, it's probably close to being in the hundreds, or probably undoubtedly in the hundreds. So if you see a high number or a letter on the left side, you're going to be in the hundreds. And remember, this is twos, right? The whole point of hexadecimal is you can have a whole bunch of digits over here or bits, whereas hexadecimal is just 2. So this is this 2, this 2, and this 2. So 60, or what we should say is 60 in hexadecimal, is actually 96 in decimal. Again, we'll go over hexadecimal later. There's a video on it, but just kind of realize that the higher the left-hand number, because this could be F, which is 16, but this is still 2. It's only 2 times 16 plus 16, which is relatively low number compared to 256. All right, so hopefully you get that, because as we go over here, you're going to go do this pixel widget by yourself. So when we're done with this video, go ahead, go to code.org. You're going to knock through this. The only thing they added to it, besides you can switch over to hexadecimal if you want to play around with that, is how many bits per pixel. So you don't have a whole lot of shades of anything when you have 3 bits per pixel, right? So you can see down here, 1, 2, 3, 1, 2, 3. You don't have a whole lot. It's all red, because remember it's binary, right? So that's all red, no green. So you can only basically do red, green, blue, and then red, whatever the shade of red and green makes, and then whatever the shade. So basically, whatever you can make with 3 bits. That's how many different colors, which is why this one's going to start you off as a good example, and it's just going to move over. So when you're finished, go finish, and then keep moving on. Level 7 and 8, you're going to try to make these the best you can. Right? Obviously, don't worry. This is that sampling concept. You're going to try to go through and make these, but also this is going to kind of lead us to compression in our next couple lessons. So let's wrap this up. What happens at each level creating a digital color? All right, so think binary. Think of how binary works, and then kind of combine that with RGB. And we went over this in the RGB section, so kind of summarize how you get binary to decimal to a color. Again, more abstraction. You have the binary, so this might help you. Binary, the pixel, the sampling, and then it's finally thing. So basically, when you're reading this, look at this. You might pause it here and try to explain what's happening. What's at the binary layer that goes into the pixel layer? Remember RGB. Sampling, we went over sampling last lesson, to it's actually what the picture is. All right, so we'll watch this video, and that will be the end of this lesson.
Hi, my name is Lamora Freed, and I'm an engineer here at Adafruit Industries. And this is where I do engineering and design, and I design circuits for fashion and music and technology.
My name is Federico Gomez Suarez, and I'm a software developer with Microsoft Hack for Good. And I look into using technology to help us solve some of the big social problems of our times.
You may have heard that computers work on ones and zeros. Or you may have seen scary-looking visuals like this. But almost nobody today actually deals directly with these ones and zeros. But ones and zeros do play a big role in how computers work on the inside.
Inside a computer are electric wires and circuits that carry all the information in a computer. How do you store or represent information using electricity?
Well, if you have a single wire with electricity flowing through it, the signal can either be on or off. That's not a lot of choices, but it's a really important start. With one wire, we can represent a yes or a no, true or false, a 1 or a 0, or anything else with only 2 options. This on-off state in a single wire is called a bit, and it's the smallest piece of information a computer can store. If you use more wires, you get more bits. More ones and zeros, with more bits, you can represent more complex information. But to understand that, we need to learn about something called the binary number system.
In the decimal number system, we have 10 digits from 0 to 9, and that's how we've all learned to count. In the binary number system, we only have 2 digits, 0 and 1. With these 2 digits, we can count up to any number. Here's how this works. In the decimal number system we're all used to, each position in a number has a different value. There's the 1 position, the 10 position, the 100 position, and so on. For example, a 9 in the 100 position is a 900. In binary, each position also carries a value, but instead of multiplying by 10 each time, we multiply by 2. So there's the 1's position, the 2's position, the 4's position, the 8's position, and so on. For example, the number 9 in binary is 1001. To calculate the value, we add 1 times 8 plus 0 times 4 plus 0 times 2 plus 1 times 1. Almost nobody does this math because computers do it for us. What's important is that any number can be represented with only ones and zeros, or by a bunch of wires that are on or off. The more wires you use, the larger the numbers you can store.
With 8 wires, you can store numbers between 0 and 255. That's 8 ones. With just 32 wires, you can store all the way from 0 to over 4 billion. Using the binary number system, you can represent any number you like. But what about other types of information, like text, images, or sound? It turns out that all these things can also be represented with numbers. Think of all the letters in the alphabet. You could assign a number to each letter. A could be 1, B could be 2, and so on. You can then represent any word or paragraph as a sequence of numbers. And as we saw, these numbers can be stored as on or off electrical signals. Every word you see on every web page on your phone is represented using a system like this. Now, let's consider photos, videos, and all the graphics you see on a screen. All of these images are made out of teeny dots called pixels, and each pixel has a color. Each of the colors can be represented with numbers.
So I'm gonna pause this right here. This is actually, if you zoom in and Google this, zoom into a pixel and actually see a picture of it, this is what it looks like. So a lot of times they're side by side, but it's these 3 lights. And they're literally, if you look really, really closely, get a microscope, look at your computer screen, every pixel, which is one little area of the screen, that's the smallest pieces, is made up these 3 lights. So this is 1 pixel on the screen, like a little bitty pixel, and it's got the red light on a lot, it's got the green light on a little bit, and it's got the blue light on a medium amount of bit. And then when you just put these all next together, that's how you see this. That's what she's saying right now. So this is a good example, and then the concept of a pixel.
When you consider that a typical image has millions of these pixels, and a typical video shows 30 images per second, now we're talking about a lot of data here.
Every sound is basically a series of vibrations in the air. Vibrations can be represented graphically as a waveform. Any point on this waveform can be represented by a number. And this way, any sound can be broken down into a series of numbers. If you want higher quality sound, you would pick 32-bit audio over 8-bit audio. More bits means a higher range of numbers.
It's sampling.
When you use a computer to write code or make your own app, you're not dealing directly with these ones and zeros, but you will be dealing with images or sound or video. So if you want to understand how computers work on the inside, it all comes down to these simple ones and zeros and the electrical signals in the circuits behind them. They are the backbone of how all computers input, store, process, and output information.
All right, so that's a really good review of everything that we've gone over, and great to understand why we're learning binary. So it's the baseline. Like, you will almost never use it, but when you see 255 again, you're probably gonna remember, that's right, that's a byte, that's 8 bits. So with that, have a good night. We'll see you next class.